Keselami itu adalah satu lebih. Dia adalah selama ini kembali.
Alright guys, so the revision session starts today. So, can you just go around and ask people any questions they have? Yeah, if you have any questions, guys, just tell me. I will happily do them in the visualizer. You should now start preparing for the exam, which is on the 23rd of May. So it's approximately 2-3 weeks from today. Yeah? Well, exactly 2 weeks from today. So 3 weeks. Exactly 3 weeks from today. So you better start preparing for it. Any questions you guys have, tell me now so I can do them. I mean, I'm sure you guys have plenty of questions. What about you? No? Just go on. You guys have any questions? You guys want to collect the test?
Yes.
Okay, first collect your test and then ask me questions. Yeah, I know. Don't make a lot of noise though, please. Don't make a lot of noise, guys. Please, be quiet. It's arranged according to your surname, hopefully. Sometimes it's your first name, I don't know. I don't know the difference between your surname and the first name, sometimes. Don't change the order, please. Alright, do you have any questions you'd like me to do, guys? Sure. Which one? Okay. All right, guys. Shh. But you all got your test paper back? Yes? You said you all happy with your mark? The marks are too high, I guess, this year. All right. One of you guys asked me to do 2000. Can you listen, please, guys? This is exam. All right, this is the exact. I don't know whether you have the question with you, but you can check it online. This is the question, right? The question says that you have a random sample from a uniform distribution on the interval 0 to theta. So you have x1, xn, IID. Right, and we want to, the first part of the question is to the first part of the question is, part 1 is to find all right, this is the first part of the question. Find the most powerful test of level alpha for the null hypothesis that theta equal to theta is 1 versus the alternative that theta equal to theta 2, where theta 2 is greater than theta 1. All right, now remember, when I say the word most powerful, what does it mean? You use what? The most powerful means you need to use the Neyman-Pearson lemma, right? Any test obtained using the NP lemma is the most powerful test. Yeah. So to answer this question, we will refer to the Neyman-Pearson lemma, right? And we say that we reject the null hypothesis according to the NP lemma if the ratio of the likelihoods at theta 1 and theta 2 is less than a constant c. I mean, you should look at the lecture notes at the last page of the printed lecture notes. You will see this formula. Right? This is the rule that the NP lemma gives to reject the null hypothesis. Right? Now we know that the data comes from the uniform distribution. So the likelihood at theta 1 is do you guys see where this comes from? This is the likelihood at theta 1 and this is the likelihood at theta 2. Right? What I have written is just the density of the uniform distribution with the indicator function. Right? Now this is where your knowledge of, okay, now let me ask you, what does this simplify to, guys? What does this simplify? I'm sure you should know this. I mean, given the formulas I have given you in the course, what would this simplify to? It would simplify to times what? Indicator at, come on guys, you should know this. The minimum of xi greater than 0 and the maximum of xi less than or equal to theta 1. Do you see where this comes from, guys? This is one of the formulas I had given you in the notes. You should look back at the notes. This is also a formula. This is also a formula that you need to remember for the final exam. You should look in the website. The formulas you need to remember for the final exam. This is one of them, right? Yeah. Yes. And similarly, okay. Similarly, you have this. Are you guys with? Oh, sorry, I forgot to put. Okay, now you can see both sides. Okay. So you see how I got from this step to this step. This is using the formula that I gave you in the notes, guys. Yeah. Now you can simplify this further, but not a lot further. So now let me call this function here. You should look at this. Yeah. All right, let me simplify this a little bit, okay, before I talk. You can take this up. You can keep this in the bottom. Then what you're saying here is the indicator function at the min multiplied by the max and in the bottom you have the min so it should be greater than or equal to, it really doesn't matter because we are dealing with the continuous distribution. Less than a constant c. Now I'm gonna we can cancel these two terms because they are the same, right? So the only thing you are left with is this term and this term, right? Okay, now if you look at the left hand side of this, that is this expression here, the only data term, when I say data I mean x1 to xn, right? What you have here in the left hand side is a function of the max of xi, right? Because it depends on the data, this expression here depends on the data only through the maximum of xi. So what you have on the left is a function which I call g. It's a function of the maximum of xi. Do you see what I'm saying? I mean, what you have on the left hand side, the expression on the left hand side, this one here, is a function of the maximum of xi, right? Which I call that function g, right? Just for short. Right now, the next thing you should do is the following. You should draw a graph. On the y-axis you have the function g, on the x-axis you have the maximum of xi. We know that theta 2, suppose this is theta 2, theta 2 must be greater than theta 1. Suppose this theta 1. Now how do you think the graph will look like? You should draw, let me bring this down a little bit. Let me bring this down a little bit here. Okay, there we are. So the function g is this one here. This is our function g. Now if we draw this function versus max of xi, it will look like the following. Let me explain. Let me sit down for if the max of xi, sorry guys, if the max of xi is less than theta 1, that is if it is somewhere here, right, then the term, this term here will be equal to what? It will be equal to, are you with me or no? Lost. If the max of xi is somewhere here, right, what would this term be equal to? It will be equal to 1, right? Yeah? And this term will be equal to 1. So 1 divided by 1 is 1. So what you have is that for all the values less than theta 1, the value of g is equal to theta 2 divided by theta 1n. So in other words, right, it will take the value even beyond this. Okay, it will take this value for all values of theta 1 for all values of max xi less than theta 1, it will take this value. Okay, do you understand? All right, now suppose the max of xi is somewhere between these 2 points, right, between theta 1 and theta 2. In that case, this term will be, it will be 0, right? 0, and this term will be 1. So 0 divided by 1 is 0. So over this range, the value of the function g will be 0. Are you guys following me or lost? Yeah. All right. Now let's take, suppose your max of xi is over here somewhere, right? Then this will be what? The value of this will be 0, right? And the value of this will be also 0. So 0 divided by 0 is undefined. So basically the function is like this, is undefined over this range, right? So the plot, what I have done here, guys, is to plot g. G is this function here, g versus max of xi, and the function, as you can see, is undefined over this space, right? It's only defined over this space, and over this space, the function is a decreasing function. Yeah, it's a stepwise decreasing function. Yeah, and therefore, now let's return to where we were. we were asking this question: if g of max of xi is less than c, then you should take inverse both sides. Will be greater than g inverse of c, because g is a decreasing function. All right. So, and you can call this, if you like, you can call this some name k, right? So the answer to the first part of this question, number 6, is that we reject the null hypothesis by the NP lemma if the maximum of xi is greater than a constant k. Right? Is that clear? Or seems some of you are lost, guys. Are you guys okay? Okay, no? Any other questions you like to do, guys? I'm sure you have plenty of other questions you want me to do. How about you? You okay? You have any questions you want me to do? What about you guys? Do you have any questions you want me to do? Come on, guys. It's only 3 weeks away. Hi. Yeah, the rejection of hypothesis. That's what the NP lemma says. Yeah. If you look at the notes. Yeah. The rejection of hypothesis is less than constant c. Yeah, when you take the inverse of g, both sides, it's less than we compare with. That's because g is an increasing function. Yeah, it will say the same. Yes, it will say the same. That's why I said in brackets, because g is an increasing function, you need to reverse the sign. You need to reverse the inequality from less than to greater. Yeah. Any other questions, guys? So, and you got your test written, right? So you want me to do the question model? Okay. How about you guys? Do you have any questions you'd like me to do? So what you said? You guys have more questions? Not yet. What about you? Do you have any questions you'd like to Oh, you guys here. You guys are always together, so you must have some questions. Huh? Yes. Yeah, yes, that's because the function g is a decreasing function. Let me explain. I know some of you ask me now. I thought you know this, guys. If g is a decreasing function and you're taking the inverse both sides, then you have to change the sign of the inequality from less than to greater than. Whereas if g is an increasing function, you take the inverse both sides, then you don't need to change you shouldn't change the sign of the inequality. Yeah? You should only change it if g is a decreasing function. Yeah, if g is decreasing and you take the inverse both sides, then you must change the sign of the inequality. Yeah. All right, guys. All right. Now let me. This is only part one. Let me do the other parts also. The second part. This is part two, guys. So let me do. All right. Here I'm done with this. All right. This is. Part two. Shh. Part two is to find pi of theta. Remember, pi of theta denotes the power function, right? And the power function is defined as the probability of rejecting h0 given the value for theta. So this is the probability that now we from part one we know that we reject the null hypothesis if the max of xi is greater than a constant k given theta, right? Now this we can write as 1 minus the probability that max of xi is less than a constant k given theta. Now if the maximum is less than a constant, right, then each element has to be, I'm sure you know that, right? If the maximum is less than a constant, then each element has to be less than a constant. So this means that x1 is less than or equal to k, and up to xn is less than or equal to k given theta. Now because x1 to xn are independent uniform random variables, you can write this as the probability that x1 is less than or equal to k given theta. Okay. Now we are told that x1 to xn are uniform random variables on the interval from 0 to theta. Now let me test your memory. If x1 is uniform from 0 to theta, what would this be equal to? You should know this, guys. It's in the lecture note somewhere. Yes? No? Don't you know that? I mean, this what you have here, guys, is the CDF of the uniform distribution. And what is the CDF of uniform 0 theta? Don't you remember this? Yes. You should, I mean, some of these formula you should know. I mean, especially the ones I listed on my website. You should know this, guys. So this is the. The power function of theta, right? So when you know that for the CDF of a uniform distribution is x over theta for the interval from 0 to theta, Just look back at the notes, guys. You will see where it is. Yeah. Is that clear to all of you guys? Yes. Oh, sorry. Oh. I conclude. All right. Any other questions you guys have, please? You want to say? You have any questions? Any questions you'd like me to do? And then this becomes x minus x divided by b. In our case, b is less than a 0. Becomes x divided by Do you guys have questions? What about you? Do you have any questions?
The probability of type 1 error.
All right, guys. Let me also do the two remaining parts. So this is part 2. Shh. This is part 2 of question 6, and let me do part 3 also. So part 3 of question 6 is to. So sorry. Where's my pen? So this is part. Sorry, can you say this? Is to find the value of k if alpha is 0.05. Remember, alpha is the type 1 error. So we are told the probability of type 1 error is equal to this, right? So which means that, remember the definition of type 1 error is the probability that you reject the null hypothesis. You reject H0 when theta is equal to theta 1. This is our null hypothesis, right? Is equal to 0.05. Now, in terms of power function, this is the same as pi at theta 1 equal to 0.05. Now we just showed a few minutes ago that pi of theta is equal to this, right? So what you have is 1 minus k All right, and all you have to do now is to solve this equation for k. So this becomes and so k becomes all right, so this is the value for k, right? Do you guys see how I got it, or is that any questions, guys? Is it clear, guys, or not? Do you see this argument that the probability of type 1 error is the same as the power function at theta equal to theta 1 because of the way it is defined? Yeah? Yeah? Is it clear or not, guys? Please talk to me, guys. Please. Oh, you haven't signed it? Sorry. And you guys all signed the attendance sheet? Yes, no?
Yes.
Okay. Guys, this is okay with you, all of you, or not? Yeah. All right. Now let me do the final part of the question. Part 4. So this is part 3, guys. Can I take this away, guys? Shh. All right, part 4. Shh. Can you listen to me, guys? The part 4 is to find the value for beta. Remember, beta denotes what? Beta denotes the probability of type 2 error, right? So beta is the probability of type and is defined as the probability that you accept the null hypothesis when H1 is true. H1 is true if theta is equal to theta 2. So you can write this as by the complement rule, this is 1 minus the probability that you reject the null hypothesis when theta is equal to theta 2. You see this? Just by the complement rule, right? Now what you have here, guys, now let me ask you, what is this equal to, guys? Just tell me, what is this equal to by definition? It's equal to, you must know this immediately what it is. It is exactly the power function at exactly here. What does it say? Long to take to say that. All right, so this is the power function. The 1 and the 1 cancel, so the answer is, all right, so that is, so this is the value for beta, the probability of type 2 error. Is that clear, guys, or not?
Yes.
Yeah. So this answers question 6 of, so every year you will get a question on the NP line. So this would be a typical question on the NP line. All right, guys, I'll see you guys in a minute. Have all of you sign the attendance sheet.
Dah move on belum? Kan lah.
Tadi ke?
Pasal dia orang pula ni.
Tadi ke?
Pasal dengan orang pula ni.
Tadi ke?
Ha.
Dalam rumah. Zuzu tu nama pula tu. Zuzu.